Hi everyone. I'm really happy to be here today with Simon, our engineering manager, and Christian Hein, CEO from Inheaden. Um, so it's been 1 year since we launched our first two serverless products in general availability, serverless functions and serverless containers. And the idea of today's webinar is, on the one hand, to celebrate this achievement. 1 year of products. There's been a lot of work for all the team at Scaleway to provide good products and improve them all along the year, and also to catch up on what we're going to do in the coming weeks and months, and discover also how you can use serverless to do great applications. So we're going to talk first about serverless, what it means and what it means to us, then do a bit of recap on what we've been doing and what we're going to do, and then introduce Inheaden on what they are using, why they're using serverless for. And feel free to ask questions in the chat or in the question section of Livestorm.
Cool. So, hi everybody. So I'm going to talk about how we see serverless as more of a philosophy. It sounds very grandiose, but really it's a driving force behind building cloud applications that are easy and cheap to use. And it's one of the things that will be driving the serverless development going forward for the next couple of years. So it's highly relevant. So we can start thinking about serverless by thinking about running code on your laptop. So running code on your laptop is really easy. You write the code, you install some libraries, then you run it. And importantly, behind the scenes, the operating system is doing loads of stuff for you to make that so easy. It's handling all the resources, it's making sure they're shared properly, making sure things are isolated, and it's fairly standardized across laptops. When you switch laptops, you don't need to change your code. You may need to recompile it, but even that's made very simple. The key point here is that the user can focus on their code, the bit that adds value to them, and the operating system does all the rest. Now, when we want to move on to the cloud, it's a little bit more complicated. I write my code, but then I have to provision a load of infrastructure. I have to then configure it, decide how I'm going to scale it, and then also connect up different services. So if I need a database, a message queue, whatever. Once I've reserved those resources as well, they're not shared. It's not like an operating system where they're shared between all the applications. I'm still paying for them. And so this feels very different. It means that I'm not just focusing on my code. I'm worrying about a load of other stuff. The provider is just providing me a toolbox, albeit a very useful, powerful toolbox. And there's a bit of managed services in there, but it still feels hard. And the reason this is important is if I am a business who's not doing anything particularly special with the infrastructure, this is a waste of time. I want to focus on my application, the bits that add value. So the solution to this is this idea of serverless. So serverless is trying to make the cloud a place where you just write your code, you upload it, and then it runs when it needs to at whatever scale it needs to. And so the provider here is kind of taking on the role of the operating system from the first example, where they're creating the infrastructure for you, configuring it. They're scaling it from 0 to what feels to you like infinity, because obviously the cloud gets these huge economies of scale, and you're not paying for it when you don't use it. There's also connecting different services part. This is something that the whole world of serverless is trying to get better at. Yes, I've got my compute, but what about my storage, my communication, etc.? And I'll talk about that in a second. The important point here, though, is that the user focuses on their code and the provider is doing the rest. Now, importantly, as a cloud provider, we're not saying that serverless will be for absolutely everybody. And an analogy that we like to use to sort of explain why is thinking about pizza as a service. So let's say I want to have a pizza party with my friends. At some point, someone somewhere will need to make a pizza. Someone will need to provide some beer. Someone will need to invite my friends, and someone will need to make conversation. This is kind of analogous to what the different layers of the stack in the cloud, which is shown on the right here. So you've got hardware, virtualization, OS, runtime, blah, blah, blah. They're equivalent to the levels of things I need for my pizza party. If I'm really good at making pizza, I've got my own pizza oven, and I've got my friends and I'm great at making conversation, I can do it all myself. Just like if I'm a business who has all the infrastructure and knows how to use it, I can do traditional on-premises legacy computing. However, there's different levels of sharing. So for example, here, let's say I don't have a pizza oven, but I still want to do everything myself. I can go to a communal kitchen where some stuff is shared. In green here, the oven and the gas supply is shared. I'm still doing a lot of stuff myself, but the bits that I either don't want to do or can't do are handled by the kitchen. So this is similar to infrastructure as a service, where the cloud gives you virtualization and hardware shared, but you do all the rest. And so rather than string this out any longer, we can look at where this goes. We go all the way up to bring your own pizza party to getting a takeaway. This is platform as a service. This is the level where, yeah, I want to have a pizza party, but I can't be bothered to cook, but I still want to have it at my house. So I get all my friends over, we get a takeaway. This kind of feels like platform as a service. Then we get to the next level, serverless. And this is more like the restaurant, where you want to have a conversation with your friends, but the pizza's not that important. This is a bit like me as a business. Yeah, I'm building, say, a marketplace, but tuning the infrastructure doesn't really make sense for me because I just want what everybody else does. So this is how we sort of obviously this isn't the sole reason how we justify it, but this is how we justify maintaining a full product offering at Scaleway. There's all the way from bare metal to serverless. So to summarize our kind of philosophy around serverless is that we want to make the cloud feel like one big computer, as easy as running code on your laptop. So today it's too difficult for many, many users. We want to make it a total no-brainer. So if everything I'm saying is true, I'm offering you something that is easier, cheaper, super easy to scale, and means that you don't have to employ a DevOps engineer. That should be a no-brainer, but it's still not. And this is the third point where we need to do more work to keep providing an infrastructure and products around serverless so that it feels as easy. And this is what Luca will describe the journey that we've taken to get here, and then we will talk about what's coming in the future.
Thanks, Simon. So back last year on the 2nd of November, we launched 2 projects after 2 years of build and test and almost 1 year of beta test. There was a lot of things to do during these 2 years, and there was as many, I think, things to do in the years that passed the product launch. Because during the beta phase, thanks to all the beta testers, we got lots of feedback, and we didn't manage to take it all into account before launching the product. So that's why on the first month of the first year of serverless, we worked on features like custom domain to enable you to have public-facing and client-facing containers of functions, and being able to deploy real-life application and not just PowerCore backend applications. We also work on improving how serverless work and how you can better deliver serverless project using, for example, Terraform clients and always improving serverless framework. We also work on lots of backend optimization to improve deployment time, code start, and security among serverless. With that in mind, we worked on secret management so that you don't have to display all your secrets in environmental variable when you write it and have it encrypted even on our side. We also will work recently on private containers and private crons to enable you to have containers functions that works without being publicly accessible, so that you can use what's coming, for example, triggers to trigger functions, new kind of triggers. And we also worked on runtime updates before, since we were really working hard on releasing the product and optimizing it. Lots of our runtime were a bit outdated, and we are now available to, you are now able to use like the latest version of Golang, Python, or Node with our serverless functions, and we are keeping to add new runtimes and new versions to it. And also, since serverless becomes more useful, we also wanted to enable you to make more resource-consuming and resource-intensive work with serverless function or serverless container, for example, to handle big data files or to perform media transformations. So we displayed 2 more tiers for functions and container, 3 GB and 2 vCPU, 4 GB of RAM.
Okay, so I wanted to put this slide in to kind of paint a picture for the landscape that serverless computing could look like. So now, today, serverless is kind of associated with a single product, which is, well, in our case, 2 products, functions as a service, containers as a service. These are really powerful tools that can, in theory, be used to run all of these applications here. And the way we like to look at them, which also corresponds with the challenges we face in supporting them, is looking at the running time and the resources used. So in the bottom left, we have some quite simple API use cases. Now, they're also latency critical. So it's really important that we work to reduce our cold starts and also make APIs easier to build. So right now, if I want to build a Django web app or use something with Symfony, I don't really think about all the plumbing below. And so for us, one of the things we want to work on is taking existing API code or microservices code and having it just work on serverless. I think that's kind of a cool idea. Then we go all the way up to the top right, to the other end, very resource intensive, not super latency critical, but very long running jobs. So we think scientific computing, machine learning training. This kind of thing is more like a batch computing service where you have a cluster and a job queue and some really high performance stuff under the hood. And so this again is the other end of the spectrum of products that we want to produce for serverless. And it's all part of, I'm going to skip a slide because this makes more sense. This is the serverless ecosystem. So this is where everything will fit. Everything from that graph of use cases will fit into this ecosystem. The thing I want to drive home here is that the products that we have today, functions and containers, are one part of this larger ecosystem that facilitates everything else. So in addition to these guys, we've got more runtimes, Rust and PHP and whatever, adding public and private container registries, which we don't have today. It just makes it easier to share and reuse things. An important part, this layer above of messaging, queuing, and events. This is really crucial for building workflows of functions and containers and building larger applications that talk to each other. Jobs, GPUs, this is a bit more on the kind of batch computing side of things, letting you get all the benefits of serverless, but with really compute intensive, memory intensive jobs. Then going back to the other end of the spectrum, kind of more edge computing, very fast, low latency things with WebAssembly is another project we're working on. Then all around that on this provider side, we've got things like logging, storage, etc. Storage is an interesting one. So right now, what we're talking about is serverless compute. But many applications are compute and data. If the data part isn't serverless, only part of your application is getting those benefits. So one of the new projects we're working on at Scaleway is serverless databases. So a database, a data store, a cache that is going to scale to 0 and scale up to infinity. Then the other part of this is the user side. So this is something that you'll see from us a bit more in the coming years, is doing more on the user side to just make it easier to access, to reduce that barrier to entry. Taking existing frameworks, making them work on serverless, building better offline testing. I know this is a real pain point for a lot of people, and it's a pain point for us when we're using our own products as well. And then building languages that, well, building frameworks and using existing DSLs for porting workflows to serverless. Now I'll go back to the challenges part. I'll skip through this. It's relatively easy to imagine the challenges that we face. Performance is a huge one. Security is a very interesting problem for us because serverless is kind of pushing the limits of shared cloud infrastructure. When you think about VMs, container as a service, you've got your dedicated resources. For serverless, we're sharing everything between all tenants. So there's a lot of work to do on maintaining security while making it fast. And then the scalability point. As we grow, we want to keep offering these economies of scale to our users. So we need to think about more intelligent scheduling, different types of instances, and just making sure that we're getting good utilization as well as providing a good product. Then on the user side, I think I've talked about this. This is essentially making it all easier. So there we go. And back to Luca.
Thank you. So the consequences of everything Simon says in our product range is that in the coming years, so 2033, we're going to focus on two main topics, which is better experience and fostering new use cases. For better experience, we're going to launch soon the integration of serverless into our observability product. So at the moment, the only means that you have to consult your logs and metrics to use Scaleway console or to use our API. And by the end of the year, you'll be able to consult everything in Grafana. So you'll be able to manage alerts, you'll be able to create your very own dashboard, to monitor what matters to you, but also you'll be able to export your logs and metrics to the platform of your choice. We're also revamping the console for serverless functions to make the experience smoother. At the moment, if you want to change parameters on the console, you have to redeploy the functions, which takes time. We're going to have a much more separate console, which will enable you to deploy your code, edit your functions, edit your custom domain, all that separately, so that it feels more instant to make change to your functions. We're also going to be integrated with our identity and access management system so that you can better partitionize who can access your functions, who can code, who can deploy, who can edit custom domains. One part that Simon mentioned that we are going to greatly improve our offline testing capabilities so that you get a quicker feedback loop on when you're testing your functions, because container is much more easy. We're going to also improve the use of public images through the integration of external registry. For example, if you have your own GitLab registry, GitHub registry, or if you already host images on Docker Hub, you will be able to push it to serverless container at no cost. And as Simon mentioned, we're going to try to provide new framework to make serverless just transparent for every use case. Thinking about use case, with the upcoming messaging and queuing projects and object storage, we're going to enable you to trigger functions, not only using HTTP requests or cron jobs, but using events and message stored in queues, streams, or simply events from when there's new objects on your object storage buckets. We're also going to introduce, as Simon mentioned, jobs and batch for every task that requires longer runtime, and make that work easier using workflows and API gateway, so that you have better control on how your applications run. And of course, we're going to add new runtimes to enable users that don't want to manage container to use Rust, PHP, and more. And regarding Rust, we're going to launch the beta today of the runtimes. We're adding some more documentation to enable you to push easier your Rust functions to the service. But starting tomorrow, you'll be able to use like serverless functions with Rust. And also, we have also big challenges, as Simon mentioned, on performance, security, enable even greater scalability. But there's more. We are focusing on serverless compute products because that's what Simon and I are doing. But other teams at Scaleway are producing and creating new serverless products that have the same capability of scalability, pay-per-use. So the billing is really proportional to what you're using, and fully managed solution. So we have messaging and queuing, which is available in private beta and will be available in public beta for everyone by Q1 2023. So basically, it's a simple eventing and queuing process, which is compatible with AWS SNS to push notification to one functions or containers or even HTTP, any HTTP endpoint, but also SQS for simple queuing patterns. These are two products that are really, I think, mainstream and standards in a way that they are compatible with lots of framework. They're compatible with Spring, with PHP framework, with Python framework. So it was important to be compatible with that. And we are also embedding in that NATS, which is a CNCF project, is somewhat going to be the future of messaging and enable great patterns. So one-to-many application, but also with the addition of Jetstream, the NATS become more polyvalent, and you can use it for basic queuing patterns or Kafka-like streaming services. And on the other hand, we have serverless database. At the moment, with managed database, you will face issue when trying to secure your access to functions. And if you want scalability and have a fully serverless application environment, at the moment you might feel limited by what we can offer with managed database. So that's why we are working with a more integrated and more scalable product, which is serverless database. So enough about Scaleway and serverless. Let's talk about how you can use it for real life projects. And I'm happy to introduce our customer and partner Inheaden and Christian, their CIO.
Hello, thank you very much for the introduction and for the invite to this webinar. Today I want to present you our use case, how we use serverless. But before I will start with a short introduction of Inheaden. So the initial community was formed in 2017, and then later in 2020 we founded the German GmbH here in Darmstadt, nearby Frankfurt in Germany. And we have over 35 customers and a team which is globally distributed. And we are now Scaleway users for over 2 years because we saw that there is a huge potential, and we really liked the idea of the European cloud. So I have one question for you. Why are 90% of the startups failing? Do you know that? It's about to having the right founding partners. And this is one of the things we found out in the last 2 years, that startups need a really good support. And there we ramped up our Tech Angel program. So you maybe know, maybe ask you, what's a Tech Angel actually? A Tech Angel is is a tech agency which gives you the power of a business angel. So what means this exactly? We as Inheaden investing in startups. That means we are providing the whole tech part and caring all about the technical problems of a startup, because you have a lot of founders which are have a good idea, a good knowledge of the branch and so on, but less tech resources. And 2 days it's really hard to find a whole team in a startup. So often the people out there require a high amount of salaries or so, and it's hard to get new members and to build up a technical team. And therefore, we launched our Tech Angel program, where we are giving you a structure and a team, and we are the CTO for the startup and providing all the technical resources. So from the design, UX, UI, then the software development, and also then the deployment in the cloud. And for that, we are mostly using serverless. And I give you some examples. For example, Follow. Follow is a platform to connect people to new interesting places. For example, if you are in a new city, or you're traveling around, you like to know a really good place where you can stay, where you can have a good meal, and so on. Mostly people are using Tinder for that, but Tinder is not intended to do it. And therefore, the founder of Follow, Tabea, came to us and brought to that a really good idea and a good branch knowledge in the hospitality sector and so on, and also market gap. But on the other side, what she's lacking, it's a team, it's the tech knowledge and the financial resources. So there we came in place, developed the whole app, the backend, and the mobile app, which is running on Android and iOS, and the backend, which is fully running on a Golang language. And this is all powered by serverless. So why we used Scaleway serverless? It's actually a B2C product. Many users could access the app in a really short amount of time. So here we have the auto-scaling of Scaleway serverless to serve very many requests at once. We have not so much external servers which are currently needed, what you see in the next slide then. We don't need a really high complex setup because it's a small startup, and first you need to have a really short time to market, and this is important for a startup. And we have there a really easy and quick deployment of our Go containers, no Kubernetes management or VM management, what we need so far. To have a better technical insight in it, I have here serverless infrastructure, the actual serverless infrastructure for the Follow backend. We have here our GitLab where our code is stored. There we push the image to the container registry, and also then deploy the image to the serverless. And this is then a serverless container for the backend API. Of course, not only a serverless container will solve all the necessary functions and so on. We have a Postgres database in the back, which is where we are doing the CRUD operations. And of course, we have also profile pictures and place pictures, and these are stored in object storage. So to speed this up a little bit faster, also in the worldwide distributed, we are using CDN here to serve the images a bit faster. And this is all then going to the mobile app, which is running on iOS and Android. Then we have also another use case, which is also using serverless. This is Simplest. Simplest is a business contact app. Maybe you know the situation when you are on a fair or so, or have a lot of business cards and you don't know how to store the business cards. Maybe you are losing some business cards, and you are on the party and met maybe a really interesting business contact, and you maybe not remember the name or so, and there Simplest comes to the rescue and makes your networking much easier and efficient to store the right contacts and to build up a visual graph of the networks and the connection between the people. And of course, you never forget the birthday of your business partner also. For Simplest, this is the founder is Gabi. She identified the pain point because she worked before with Excel sheets. She got a really good network in the field where she's working, and the really high need is the data privacy for Simplest. What she's lacking is a team. So she got no tech team there. Also, the technologist is lacking, and she got a bad experience with another agency from abroad, where we needed to rebuild the whole backend and the app to make it work. Also here, why we're using serverless here, we need a really high degree of privacy. The whole Simplest backend and app and so on is built on a European only tool stack. So we are not using any US companies or so for processing of the data, which is really important, which was also proved by a lawyer and so on. And this is one of the most important things because you're handling a lot of customer data. Also here, we have a few external services which we need here. And of course, the time to market, there's no high complexity for the startup, what we need here. And of course, we have the easy and quick deployment of the containers, which is also built fully in Golang. Also here, I have the infrastructure. It's a little bit similar to the follow ones, but actually we have here, of course, the GitLab to store the code and then push the image to the container registry. And here we have also our serverless container front end, which is serving the web app. And then, of course, our backend API, where all the data is get from, which is giving us the whole backend for the app. There we have also web app and also mobile app, which is running on iOS and Android. In the object storage here, we are storing, for example, profile pictures or business cards. Then we have, of course, here our CRUD operations to the Postgres database. And for long-running requests, we are using the Scaleway Nets messaging queue. My colleague Lars Gruber also wrote a really nice article about it, how we solve to mitigate long-running requests with this messaging queue. Yeah, all in all, this is the infrastructure, and it's working quite well. And we are really happy to have the Scaleway serverless infrastructure and the product to solve our needs. Yeah, thank you very much for the invitation and the webinar here. And I have a short question for you. Which project we could empower next for you with Scaleway serverless?
Thank you very much, Christian. So now it's time for the Q&A. There's already a bunch of questions in the question side. If you have any other, please add them. So I've seen that Simon started to answer some of them. So the first question is, will we get the slides? You won't be able to get the slide, but the session is being recorded, and you'll be sent a link to this presentation. The second one, can you detail the technical aspect of your messaging queuing architecture? Simon?
Yes. So basically, the idea with the messaging and queuing project is to build a more generic orchestration system. So tomorrow, or the next features will be, first of all, messages from queues to functions and containers. but then there will be S3 events, and then there will be functions to functions, and then there will be whatever source of events you want from the Scaleway ecosystem or outside, triggering your functions in a workflow. So the architecture is fairly generic. It's us sending events from one source to a sink. And it's based on just standard open source streaming libraries. And yeah, I think it's kind of cool. Like it'll be a fairly generic architecture where you can build not just serverless products, maybe. You could connect up an S3 event to a queue to a database. Now, the big question for us is how users will write applications for this. So there are various open source workflow projects that we could integrate with. There's some domain-specific languages that we could integrate with. And so the next question for us is how we're going to let people access it. So if you have any suggestions on how you would like to write things for a serverless orchestrator at Scaleway, that would be really good.
Thank you. Hope it answers your questions. If you have any remark, post it in the chat. Next one, how important is for you to be compatible with serverless.com framework and console? So as I can take this one, as Simon already gave you an answer, but regarding serverless console, it's not planned at the moment to be compatible with any of serverless other projects apart from framework. That's something we need to think about. Framework is widely used across the serverless community. I'm not sure that console is at the moment also used, but if I'm wrong, you can of course correct me. The idea is that we are thinking about being referenced as an official plugin, because for at the moment we are only providing a functioning serverless functions and containers plugin, but we're not referenced on serverless.com website and documentation. So that's one of our goals. But regarding the console, it's going to be, we need to decide if we want to be compatible. Next question, will the serverless database be relational or NoSQL/document based? It's not yet act on which model we are going to, which database model we are going to be. Stay tuned and subscribe to the beta page of serverless database to get more information about that. Probably the two model, but it's not sure at the moment. Next question, what is the ETA of HTTPS only mode for serverless? Simon, you can give more detail.
Yeah. Hi, Camille. I just answered. Yeah, it's in staging now. So if it works, we should push it out early next week. But I would never say never on something. But yeah, don't worry, we're working on it.
And it's going to be available first through API and serverless framework, and then on the console, of course. Next question, a bit more technical. Today, it's possible to scale up and down based on the amount of concurrent requests. Is it planned to have the possibility to scale according to the resource load?
I can answer this one. So basically, serverless scheduling, as I showed you, that ecosystem of use cases that we have means that there is no one-size-fits-all scheduler and auto-scaling method. For us, we really need to basically pick. Yeah, unfortunately, the way the system is architected now, we need to pick a one-size-fits-all. Right now, the concurrent requests works for a lot of people. The possibility, the approach I would like to take is offer people a scheduling option, because if you have a very compute-intensive task that runs for a long time, if you have that, if it's queued if something is queued behind it, you have a low number of concurrent requests, but a lot of resources. So it's a very good question. The answer is not so simple, but I think the solution is probably exposing different options for scheduling. So based on CPU, memory, queuing time. We need to think about changing the architecture to allow different schedulers, though. Happy to discuss this on the community Slack, though, because it's obviously very important for us to know what you want to scale on.
Very clear, thank you. Next question, and I see that Christian is replying. How can we request support for our software development, DevOps, and cloud topics? What were you writing, Christian?
Yeah, I think it's more a general question regarding general support in that field. Yeah, if you need support in this field, or maybe some you have ideas or so, you can contact us under Inheaden.io on our website, and or get directly in contact with us. We are present at the Slack channel really often, and there we can speak about your ideas and interests and about support. And yeah, also our Inheaden website is powered by Scaleway Serverless. Yeah.
Thank you. So I think that's it for the questions. The chat.
Yep, I think, yep. So for everyone waiting, thank you for listening to your presentation and also for your questions. So as a part of attending the presentation and 1-year anniversary, we are providing a €300 cloud credit, which can be used €100 per month. And the voucher is valid till February 17th, and the voucher is available in the chat right now. So you can use this to get started with Scaleway and using our resources. Also, you will receive a mail containing more details about how to use the coupon code, which will be communicated to you in the coming days. And well, that's the end. Thank you, Luca, Simon, and Christian for this great presentation, and also everyone for joining and also having an engaging conversation. As you mentioned, you will receive the recording at the end of the day. If you have any further questions, you can reach out to us at events@scaleway.com. We wish you a wonderful day, and we hope to have you see you soon in the further events. Have a nice day, everyone. Bye.
Have a nice day. Bye.
Have a nice day. Bye.